Today's lesson is simplifying radicals. I've gone ahead and I've set my paper up to do 2-column notes. I've titled my paper. This is my first page of notes, so I've gone ahead and numbered it. Notice I've taken my ruler and I've divided it in half because it is 2-column notes. And then at the bottom of the page, I've left myself a little bit of space for some summary of notes, or today I'm actually going to kind of start down here at the bottom, and I want to talk about what a radical is and what the vocabulary is that goes with it, and some previous information that we're going to need for this lesson. So let's go down here, and in the summary at the bottom of our page, let's start there. Let's start with some vocabulary. So most of the time when people talk about radicals, they actually use the phrase square root. Square root's a specific kind of radical. This symbol itself is a radical. You'll sometimes hear it called the square root symbol. I'm going to call it the house a lot because that's just kind of the phrasing that I use to talk about how we're going to solve these radicals. Now, it's a square root based on what number is in this spot right here. There's nothing there right now. If there's not a number in that spot, then it's considered a 2, kind of like an understood 1. It's an understood 2, which means we're dealing with square roots. This is the index number, though, and as we go through talking about radicals, the index number is going to change, and when the index number changes, that changes something that we're looking for in our radicals. And then everything that's inside the house, so everything that would be in here, I'm just going to put an XYZ for right now. Everything that's inside the house is called the radicand, and that's actually what we're going to be simplifying. It's kind of like the radical is like a plus sign or a minus sign or telling you to multiply. It's telling you to look for certain groups of prime factors. And that's how we're going to do this lesson. We're going to do this lesson by using prime factorization. So just to remind ourselves, let's write some prime factors down here. We don't need a lot of prime factors because we're not dealing with any really huge numbers. And plus we want all of the prime factors, and at some point the prime factors of any number are going to get kind of small. So prime factors start with 2 because a prime factor is a number whose only factors are 1 in itself. So 2 can only be divided by 2 and 1. And then 3 and 5 and 7. And even though I always want to make 9 a prime factor, 9 is not a prime factor. It's actually a perfect square. So I got to skip 9 and 11. Those 5 numbers right there as prime factors should get us basically everything that we need in the next few lessons to simplify our radicals. So let's go back and let's look at the first radical that we want to simplify. The first thing I want to do, the first one I want to simplify, is the square root of 60. Now, anytime it's a perfect square or it's a square root, I want you to check and see if it is a perfect square. You know a lot more perfect squares than you think you do. You're like, I don't know those, but you actually do. You know that 2 times 2 is 4, so you know that 4 is a perfect square. You know that 3 times 3 is 9, so you know 9 is a perfect square. So what we want to do is, if we're not sure, when the numbers get a little bit bigger or they get into that part of the multiplication tables where we sometimes stumble around, let's just go ahead and go into our calculator and let's check and see if 60 is a perfect square. If 60 is a perfect square, the number that I'm going to get right here is just going to be a whole number, no decimals. I don't want any decimals right now. Unfortunately, 60 gives me this big long decimal, and that's not what I'm looking for. I'm looking for a perfect square. So that means I need to simplify the square root of 60. So to do that, the first thing we're going to do is we're going to do prime factorization. Now, you may have heard me in class or just in passing call it the upside down birthday cake. That's kind of what it ends up looking like. So we're going to start with 60, and we're going to pick a prime number. I always like to start with the smallest prime number. So if anything is divisible by 2, start there. So we're going to start with 2, and 60 divided by 2 is 30. 30 is still an even number, so we can still divide by 2. And 30 divided by 2 is 15. It's like doing your multiplication or your division upside down. Now, 15 is not an even number, so we're going to have to look for the next prime number that goes into that. We know that 15 is divisible by 3, so we're going to divide by 3. 15 divided by 3 is 5. And the only thing that goes into 5, because 5 is a prime factor that we listed at the bottom of our page, is 5, and 5 divided by 5 is 1. Remember, we call this an upside down birthday cake because it ends up being a stack, and on the top, or in this case on the bottom, you end up with the candle, which is the 1. Now, so there's our prime factors, and what we want to do after we get our prime factorization is we want to look for pairs. So that's the second step that we want to look for pairs because we're talking about square roots. So we're looking for a number times itself. Just like a perfect square, 4, the square root of 4 is 2. That's 2 times 2. We're looking for the same amount of numbers, and they have to match. So we get a pair of 2's right here, and we're going to go ahead and circle those because I want to make sure that I know where they're at. And sometimes if you don't stay with even numbers and you divide by 3 or you see 5 first, sometimes your numbers won't end up right next to each other in order like they did here. Mine are pretty much going to all end up in order because I've done this a lot and I'm pretty used to doing it. So we're going to look for the pairs. And then what we're going to do is we're going to take the pairs outside. So over here, let's write what we're going to do. The pairs, so that pair of 2's, go outside as 1. They don't get multiplied back together. They stay at 2. That's a pair of 2's, so 2 goes outside. Now, these leftover guys, the leftovers I'm going to call them, the leftovers stay inside. So, the radical is still there. I have a 3 and a 5 that were left over, so 3 times 5, because remember we divided to get those numbers. So we're going to multiply those back together. And then if you have anything inside, you want to multiply it back together. So we're going to keep the 2 on the outside. It's the only thing that's out there. And then we're going to go the radical. 3 times 5 is 15. So I want you to check your work. So let's grab our calculator. Here's the square root of 60. We can check our work by taking this simplified radical and typing it into our calculator and looking to see if it matches this one exactly. So let's just remember 7.745. And then we're going to say 2. Oh, I didn't want to shift there. 2 square root of 15 is 7.745. So that matches the big long decimal that we got. So what did we do? We multiplied anything that stayed inside. So we looked for pairs. The pairs went outside as 1. The leftovers stayed inside. So that 3 and that 5 that were left over stayed inside. They got multiplied back together because they stayed inside together. So we just multiplied them back together because there's no sense in having a 3 and a 5 wandering around in there. And we were left with the square root, or the 2 square root of 15. And so the last thing you want to do is check your work. It's really easy. You just type it in the calculator. So, pretty simple. Nothing overly complicated here. Nothing new to you. Just using what you know in a different way. So let's go and let's do a slightly bigger number. So let's do the square root of 108. So we're going to do prime factors and pairs. So we're going to find the prime factors and we're going to find pairs. So let's do our upside down birthday cake. Prime factors and pairs is where we start. So we take our 108 and 108 is an even number. So we're going to divide by 2, which gives us 54. 54 is an even number, so we can divide by 2 again, which gives us 27. 27 is not even, but it is divisible by 3. And 27 divided by 3 is 9. Oh, look at that. There's 9. It showed up. 9, we know, is divisible by 3. 9 divided by 3 is 3. And the only thing that will go into 3 is 3, and that leaves us with our birthday cake on the bottom side of, or our candle on the bottom side of our birthday cake. So we've done our prime factors. Now let's go look for our pairs. I have a pair of 2's right here. I'm going to put them in a circle. I have a pair of 3's right here. So the pairs get to go outside. Remember, that was the first thing that happened, or the second thing that happened up here. We looked for pairs, and then the pairs got to go outside as 1. So this pair of 2's gets to go outside the house. This pair of 3's gets to go outside the house. And this leftover 3, I like to say he has no friends, so he had to stay inside. So now what happens if I end up with 2 numbers that went outside? So I have more than one pair. That's what I've got here, more than one pair. So let's make a note here. What happens if I have more than one pair outside? We're going to multiply them. So that becomes 2 times 3, and 2 times 3 is 6. That 3 that didn't have any friends that had to stay inside stays inside. And then we want to check our work. So we're going to take that calculator. We're going to say the square root of 108 is 10.39. And let's see if 6 square root of 3 matches that 10.39. So 6 square root of 3, nothing changed. So we have the correct simplification of the square root of 108. So what you're seeing is that we're looking for pairs. The pairs get to go outside. Anybody who goes outside gets multiplied together, and anybody who stays inside gets multiplied back together. So we're taking our numbers apart and taking our numbers apart all the way down to their simplest number, all the way down to all of their prime factors. And then we're sorting those prime factors out. So what if there's already something outside? So what if I started with a number outside the radical, like 7 square root of 32? I know that 32 is not a perfect square, so I'm going to come over here and I'm going to do the prime factorization of 32. So 32 is a positive or is an even number, so I'm going to start with 2, which gives me 16. Still an even number, so I'm going to do 6. I'm going to do 2 again, which gives me 8. Still an even number. Lots of even numbers here with this 32. 4 divided by 2 is 2. And then 2 divided by itself leaves me with a 1 on the bottom of the birthday cake. So I look for pairs. I have a pair of 2's here. I have a pair of 2's here. And then I have this leftover 2. What you have to make sure that you do is don't forget the leftover 2's or the leftover 3's. Whoever's left over, don't forget that they're there. Try to keep your work as neat and organized as possible, because that's actually where the biggest mistakes are made, is when people lose a number because they've got things strewn all over the place. So what we're going to do is we've done our prime factors, we've got our pairs. Each pair gets to go outside. So I take a 2 outside, I take a 2 outside. There was already a 7 there, so guess what? It's still there. It didn't disappear. And then the 2 that didn't have any friends, he didn't get to go outside, he stays in the house. So what we're going to do is we're going to take all these numbers that are outside, even the 7 that was already there, and we're going to multiply those together. So 7 times 2 is 14, and 14 times 2 is 28. So we got 28 square root of 2. And we can check our work. Let's check our work in our calculator. So we're going to go 7 square root of 32 is 39.59. So 28 square root of 2 should also be 35.59. And it is. Yay, we got that one. So look for pairs. Look for pairs. Multiply. Let's see if I can spell multiply, doesn't it? No, that was right. Multiply the outside numbers. Multiply the inside numbers. So that's all we have to do to simplify a radical. Look for prime factors, find all of our prime factors, look for the pairs among those prime factors. The pairs get to go out. A pair of 2's goes out as a 2. A pair of 2's goes out as a 2. A pair of 3's goes out as a 3. Multiply anything that got to go outside or anything that was already outside gets multiplied together. Anything that had to stay inside gets multiplied back together. That's all you have to do to simplify a radical.